In this video, we'll be looking at a couple of different ways to evaluate logarithms, and we'll also be looking at one application problem. Well, for now, one of the best ways we have for evaluating logs is actually to think about the exponential equation they represent, and then use mental math to figure out what the unknown exponent must be. So for example, if we have log base 4 of 64, we can convert this over to exponential form. We know that a logarithm is just asking the question 4 raised to what power equals 64? Because the logarithm always equals the exponent. So in this case, we can say, well, I know that 4 squared is 16, times 4 again gives me 64, so 4 cubed must be 64. Which means that x is 3, or in other words, log base 4 of 64 equals 3. Moving on to this next one, you kind of can't see the fraction bar here, but it's there. So this logarithm is asking us 3 raised to what power would give us 1/9. Right? So we can rewrite that as an exponential equation. Now, kind of a side note here, if you remember your negative exponent rules, you remember that a raised to a negative exponent is the same as 1 over a to the n, right? So a to the negative n is the same as 1 over a to the n. Well, we also know that 3 squared is 9, which means that if I need to get a 9 in the denominator here, I can really just think about this as 3 to the negative 2 would give me 1 over 3 squared. Right? These are equivalent based on this negative exponent rule, which is the same as 1 over 9. So that means that x must be negative 2, which means that log base 3 of 1/9 must equal negative 2, to answer our original question. Log base 8 of 8. Remember, this logarithm is just asking us 8 raised to what power equals 8. So 8 to the x equals 8. Well, in order for this equation to work out, it must just be that 8 is being raised to the first power. So 8 to the first equals 8, which means that x is 1. So to answer the original question, log base 8 of 8 equals 1. Now there's one special logarithm we haven't talked about so far that gets written a little bit differently. You may notice that seems to be a missing base here, right? We have not written any base in. Well, that's because there's one logarithm that shows up so much more than others that when we use it, we actually just leave the base off. So a log with no written base has a base of 10. That's just a rule to remember. So that means in this case, this is really log base 10 of 1,000, which means that the exponential equation this goes with is 10 to the x equals 1,000, right? 10 raised to what power equals 1,000? Well, we know that 10 squared is 100, and then 10 to the third is 1,000. You can kind of just count the zeros, which means that x in this case must be 3, or in other words, log of 1,000 equals 3. Now, up to this point, you might be wondering, what use are logarithms if we always just convert back to exponential form? And eventually, we will be able to solve pretty much every logarithm on our calculator, but for now, we only are going to be using log base 10. And the reason for that is that your graphing calculator has the log base 10 button on it. It is, if you have a TI 83 or 84 or 89, it is right next to the 7 button, and it says log. So if I wanted to evaluate this problem, then I can just go ahead and put it right into my graphing calculator. which when you type it in will look like this. Log, it will open the parentheses for you, you will type in the number, close the parentheses and hit enter, and when you do so you will get that log of 271 equals about 2.433. That brings us to our last part of this video, which is the application problem. Sorry, this one's running a little bit long. The pH or acidity of rain can be determined using the formula pH equals negative log of H+, where H+ is the concentration of hydrogen ions in moles per liter. So the question we're being asked is, what is the pH of a rain sample if the hydrogen ion concentration is 0.0000316 moles per liter? Well, we have a formula right here to use. You can go ahead and fill in the piece we know. pH equals negative log of H plus, in this case, is 0.0000316. And again, this is log base 10. There's no base there. So this can go straight into our graphing calculator, giving us the pH is 4.5, which if you are taking chemistry, you know that means that this is acidic, or at least mildly acidic.